Good morning, children. Today we will be starting with a new lesson, Coordinate Geometry. Before starting with the topics of syllabus 10 or class 10, let me review what has been taught to you in class 9 regarding coordinate geometry. If a point is given on a line, suppose you are given a point P on a line, you can clearly determine the position of the point P, or we can clearly determine what real number the point P represents. That is, if a point P is given on a line, by plotting the numbers on the number line or by making the line as a number line, we can clearly fix the position of the point and attach a real number to the point P. But what about the case when the point P is plotted in a plane? Suppose you are given a point P in a plane. How do you represent the position of the point is by plotting two perpendicular number lines with the meeting point as the starting point O or 0, and towards the right on the horizontal axis we mark the positive numbers, towards left the negative numbers, and we call this horizontal axis as x o x dash, and on the number line, the vertical number line, the positive numbers towards the top position and the negative numbers towards below, and we call it as the y-axis as y o y dash. And now the position of this point is determined by the perpendicular distance of this point from the x-axis as well as the y-axis. The point P will be denoted with an ordered pair xy, where x will be the distance of the point P, the perpendicular distance of the point P from the y-axis, and the y-coordinate will be the perpendicular distance from the x-axis. That means the x-coordinate will be the perpendicular distance from y-axis, and the y-coordinate will be the perpendicular distance from the x-axis. We also call the x-coordinate as abscissa and the y-coordinate as ordinate. Thus, to represent a point P in a plane, we need two perpendicular number lines, and we call it as a coordinate system or a Cartesian plane, which divides the plane into four quadrants, 1, 2, 3, 4 in the anti-clockwise direction, and the position of the point P will be represented by an ordered pair xy, where x is the perpendicular distance from the y-axis and the y-coordinate will be the perpendicular distance from the x-axis. The x-coordinate is also named as abscissa, y-coordinate is called as ordinate. Now, to begin with, the first topic in class 10 is the distance formula. What is the meaning of distance formula, or what is its meaning? If you have a coordinate system and there are 2 points in the coordinate system which is represented by x1, y1 and x2, y2, by distance formula, the meaning is you have to find out the distance between the points P and Q. That is, what is the length of the line segment PQ. So, distance formula is dealing with the distance between any two points P x1 y1 and Q x2 y2 in the coordinate system. What is the formula? If you draw perpendicular from the point P, and this distance will give you the coordinate x1. Similarly, the perpendicular from Q and from the origin, the distance is x2. Similarly, the perpendicular and this distance will be y1 as well as this distance will be y2. If you draw perpendicular from P and call it as PT, perpendicular to QN, you can form a right triangle PTQ. If you find out, if you apply Pythagoras theorem, you will be getting the value of PQ. Let's find out what is length PT. ON is x2, OM is x1, which shows that MN is x2 minus x1. Therefore, PT also corresponds to x2 minus x1. Similarly, the distance from T, the distance OU is y1 and OV is y2, which shows that distance UV is y2 minus y1, or it corresponds to QT also. Therefore, in triangle PTQ, by Pythagoras theorem, PQ is equal to square root of PT square plus QT square, which is the same as x2 minus x1 the whole square plus y2 minus y1 the whole square. Thus, distance between two points P x1 y1 and Q x2 y2 in the coordinate system is found out using the formula PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is the distance between two points P x1 y1 and Q x2 y2 is found out using the formula PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. The derivation is not compulsory for you, only the formula you have to understand. And let's proceed with the exercise questions. Exercise 7.1. Question number 1. Find the distance between the following pairs of points. The first is subdivision 2, 3, 4, 1. 2, 3 and 4, 1. Once you get the points, just name the points as either A, B or PQ and so on. Till you study to apply the formula, you can just note the points as x1, y1 and x2, y2. The formula AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square root of 4 minus 2 the whole square plus 1 minus 3 the whole square, which is the same as 4 minus 2 is 2 square plus 1 minus 3. Subtraction of integer is by the inverse operation. It is minus 2 the whole square root of 4 plus 4, which is equal to root 8, or it can be written as 2 root 2 units. 2 root 2 units. The second subdivision minus 5, 7 and minus 1, 3. Minus 1, 3. Capital A and B. x1, y1, x2, y2. AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, square root of minus 1 minus minus 5 the whole square plus 3 minus 7 the whole square. Subtraction of integers, change it into addition, change the sign of the second integer. Addition, change the sign of the second integer, which is the same as 5 minus 1 is 4 square plus 3 plus minus 7 is minus 4 square. Square root of 16 plus 16 root 32. How do you represent it? 32 divided by 2 is 16, 8 by 2, 4 by 2, 1, which shows that it is 4 root 2 units. Number 3. AB and minus A minus B. AB is equal to square root of minus A the whole square plus minus B the whole square, square root of plus negative, that is minus 2A the whole square plus minus 2B the whole square, square root of 4A square plus 4B square, square root of, you can take 4 as common, into A square plus B square. Since multiplication is involved here, square root 4 is 2 and square root of A square plus B square. Further simplification is not possible. Leave it as square root of A square plus B square. So the final answer is 2 square root A square plus B square. Question number 2. Find the distance between the points 0, 0 and 36, 15. Can you now find the distance between the two towns A and B discussed in section 7.2? So the first part we will do it. Second part, please read what is the explanation given in page number 156. Find the distance between the point 0, 0 and 36, 15. Question number 2. And 36, 15. A, B. Distance AB is equal to square root of 36 minus 0 the whole square plus 15 minus 0 the whole square, square root of 36 square plus 15 square. What is 36 square? 36 into 36. Square root of 1296 plus 225 square root of 1521. How to find out square root by long division method? From the right in 2's, the next perfect square to 15 is 3 3's are 9. 15 minus 9 is 6, 21. Double of 3 is 6. The last two digits have come down, so the chance is 69 into 9. 9 9's are 81. 6 9's are 54 plus 8 is 62, which is equal to 39 units. Question 3. Determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. The points are 1, 5, 2, 3 and minus 2, minus 11. How do you know that 3 points are collinear is, if you name the first point as A, B and C, you can find AB by distance formula, you can find BC by distance formula, you can find AC by distance formula, and if the sum of any two gives the third one, it need not be AB plus BC is AC. The sum of any two, if it gives the third one, we can say that the points are collinear. Now, this question, there are two methods of working out. The first method is using distance formula, and the second method is by the third topic in this lesson, area of triangle. We will do the first method now, but probably it is easy if you work out with area of triangle later for the exam. Let's see how to work out using the distance formula. AB is equal to square root of 2 minus 1 the whole square plus 3 minus 5 the whole square root of 1 square plus minus 2 the whole square root of 1 plus 4 root 5 units. It is an irrational factor. You can just leave it as such. Let's see the measure of BC. BC is equal to square root of minus 2 the whole square plus minus 11 minus 3 the whole square root of minus 4 the whole square plus minus 14 the whole square, which is equal to square root of 16 plus 196 root 212. Let's make it as a mixed third, 106 by 253, or it is 2 square root 53 units. And in both answers you got two different irrational factors which cannot be added, which shows that the points are, therefore the points are not collinear as AB and BC have different irrational factors, and hence we cannot add it. Question number 4. Check whether 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. The vertices are 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. How do you know that a triangle is isosceles? Is if any two sides are equal. Now call it as A, B, C. You can find out what is the length of the side AB. Square root of 6 minus 5 the whole square plus 4 minus minus 2 the whole square root of 1 square plus 6 square root 37 units. What is BC length? Square root of 7 minus 6 the whole square plus minus 2 minus 4 the whole square, 1 square plus minus 6 the whole square, 1 plus 36 is again square root 37 units. Now since you got already the two sides equal, there is no point in calculating AC. You can give a conclusion as, since AB equal to BC, these points are the vertices of an isosceles triangle. Isosceles triangle. Question number 5. In a classroom, 4 friends are seated at points A, B, C, D as shown in the figure. Champa and Chameli walks into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. If you look at the grid, you can find out the coordinates of the point A, B, C and D. Point A represents the x-axis first and the y-axis in the second point as 3, 4. Then B represents the point 6, 7. C represents the point 9, 4. And D represents the point 6, 1. Now the question is to check whether it is a square or not. There are two conditions to be fulfilled to prove it is a square. As the first property is all sides are equal. The second property of the length of diagonals also equal has to be proved. For a square, you need to prove that all sides are equal, and the second condition of diagonal is also equal. What about for a rectangle? For a rectangle, you need to prove that pair of opposite sides equal, pair of opposite sides equal, as well as the property of diagonals also equal. If you can prove the conditions as specified here, you can determine whether the 4 points are the vertices of a square or a rectangle. AB is equal to square root of 6 minus 3 the whole square plus 7 minus 4 the whole square, which is the same as 6 minus 3 is 3 square plus 7 minus 4 is 3 square, square root of 9 plus 9, or it is root 18 units. What will be BC length? 9 minus 6 the whole square plus 4 minus 7 the whole square, square root of 3 square plus minus 3 square, root 9 plus 9, again root 18 units. CD length is 6 minus 9 the whole square plus 1 minus 4 the whole square, square root of minus 3 the whole square, another minus 3 the whole square, root 18 units. What about DA? DA length is square root of 6 minus DA, 6 minus 3 whole square plus 1 minus 4 the whole square, 3 square plus minus 3 square, which is again 9 plus 9, root 18 units. That means you got all 4 sides as equal. Now let's prove what is the length of the diagonals AC and BD. Diagonal AC is equal to 9 minus 3 the whole square plus 4 minus 4 the whole square, square root of 6 square plus 0 square, root 36 is again 6 units. Diagonal BD, 6 minus 6 whole square plus 1 minus 7 whole square, 0 square plus 6 square, root 36, which is equal to 6 units. So this 4 points will represent a square, and we can understand that what Champa said is correct. That means ABCD will represent a square. How do you give a conclusion? Since all 4 sides are equal, all 4 sides are equal, and diagonals also equal, these 4 points will represent a square. Or you can say the 4 points are the vertices of a square. Number 6, name the type of the quadrilateral formed, if any, by the following points and give reasons for your answer. So given 4 points, definitely you have to calculate the 4 sides as well as the diagonals. Based on that, we can determine what type of quadrilateral these points will represent. So I request all the children to switch off the video now. Find out the measures of all the 6 sides and see what type of quadrilaterals you are getting. I will also do, you can double check your answers from the video. AB is the same as square root of 1 minus minus 1 the whole square plus 0 minus minus 2 the whole square, square root of 2 square plus 2 square, 4 plus 4 is root 8 units. BC is the same as A, B, C, D. -1 the whole square plus 2 minus 0 the whole square, square root of 2 square plus 2 square, root 8 units. CD, -1 the whole square plus 0 minus 2 the whole square, square root of -2 square plus 2 square, root 8 units. DA, square root of -3 minus -1 the whole square plus 0 minus -2 the whole square, -2 square plus 2 square is root 8 units. Let's see the diagonals of AC and BD. Diagonal AC is the same as square root of -1 minus -1 the whole square plus 2 minus -2 root 16, which is equal to 4 units. Diagonal BD, BD is -3 minus 1 the whole square plus 0 minus 0 the whole square, root 16, which is equal to 4 units. Since all 4 sides and diagonals equal, these are the vertices of a square. Vertices of a square. Second one, AB is equal to square root of 3 minus -3 the whole square plus 1 minus 5 the whole square, 36 plus 1 plus -5 is, which is equal to 16, or root 52. Root 52 can be written as by 226 by 2 is 13, or it is the same as 2 root 13 units. BC is equal to square root of 0 minus 3 the whole square plus 3 minus 1 the whole square minus 3 square plus 2 square, 9 plus 4 root 13 units. CD can be found out as square root of 1 minus 0 the whole square minus 4 minus 3 the whole square, 1 plus 49 root 50 units. Can also be written as 5 root 2. DA, square root of -1 minus -3 the whole square plus -4 minus 5 the whole square, 2 square plus -9 the whole square, 4 plus 81 root 85 units. Let's find out what is AC and BD. AC is equal to square root of 0 minus -3 the whole square plus 3 minus 5 the whole square, 9 plus 4, which is equal to root 13 units, and BD is equal to -1 minus 3 the whole square plus -4 minus 1 the whole square, -4 square plus -5 square, 16 plus 25 root 41 units. We can see all the measures are different, but the BC length and AC length, if you take, both are root 13 units, and BC plus AC and AB length is corresponding to 2 root 13, which shows that the points A, B, C are collinear. Out of the 4 points, if 3 points are collinear, there cannot be a quadrilateral formed with these 4 points. So you can give a conclusion as, since AC plus BC is equal to AB, the points A, C, B are collinear, and so no quadrilateral is formed with these points, or these 4 points will never represent a quadrilateral. Third subdivision, the 4 points are 4, 5, 7, 6, 4, 3 and 1, 2. AB is the same as 7 minus 4 the whole square, 6 minus 5 the whole square, 3 square plus minus 1 square, 9 plus 1 is 10, to 10 units. BC minus 3 square plus minus 3 square, 18 units. CD 1 minus 4 the whole square, 2 minus 3 the whole square, minus 3 square plus minus 1 square, to 10 units. DA 1 minus 4 the whole square, 2 minus 5 the whole square, minus 3 square plus minus 3 square, which is equal to root 18 units. So we got one pair of, both the pairs of opposite sides equal. And now we have to see what is the diagonal representing. If it is the diagonals are equal, we can go for a rectangle. If the diagonals are not equal, it will represent a parallelogram. Let's see what is the measure of AC and BD. AC is equal to square root of 4 minus 4 the whole square plus 3 minus 5 the whole square, which is equal to 0, plus minus 2 square root 4, which is equal to 2 units. BD length square root of 1 minus 7 the whole square plus 2 minus 6 the whole square, square root of minus 6 square plus minus 4 square, square root of 36 plus 16, which is equal to root 52 units. Now you see, pairs of opposite sides equal but diagonal is not equal, therefore these 4 points will represent a parallelogram. Since pairs of opposite sides are equal but diagonals unequal in length, these 4 points will represent a parallelogram. It will not represent a rectangle. It will represent a parallelogram, because a parallelogram, pair of opposite sides are equal. The remaining questions we will do in the next class.